Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on frequency modulation. Okay, so this video, I'm going to explain why AM broadcasts disappeared. This video, I'm going to explain why we actually switched to frequency modulation. In the old days, basically we will be on the amplitude modulation. Okay, so nowadays, we don't have any more AM broadcasts. We still have FM broadcasts. So this video, I will share the advantages and also the disadvantages of frequency modulation and also amplitude modulation. And therefore, from here, you will be able to appreciate why frequency modulation actually dominate over amplitude modulation. This will be the part 2 series discussion on frequency modulation. So guys, if you're keen to know more about frequency modulation, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on frequency modulation. This is my email. If you have any question regards on this discussion, please drop me an email. Or if not, if you want to have a faster response, you are always welcome to ask me your question through the comment. Before I continue, I'd like to urge you guys to help this channel by pressing the like button. So guys, it's free. Only just take a few seconds. Help me smash the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for your strong support. Let's quickly take a close look the key difference between amplitude modulation and also frequency modulation. Let's start on amplitude modulation first. From this diagram here, you can see that there are actually three signals. The first signal will be the modulating signal. This is the signal that we actually want to send over to the recipient. Okay, so modulating signal is also known as baseband signal or intelligent signal. This is a carrier, like the name implies, it actually helps to carry the information over to the recipient. If you take a close look against these two signals, you realize that the carrier typically has a higher frequency as compared to the modulating signal. What is a modulated signal? In short, a modulated signal is basically a combination of the modulating signal and also the carrier. You can see that basically for modulated signal, the amplitude, for frequency modulation, the amplitude of the modulated signal actually change according to the modulating signal. So from here, you can see that the frequency will be the frequency of the carrier, and the information, basically will appear at the peak value of the modulated signal. So basically, this is what is amplitude modulation. The information or the modulating signal actually appear at the envelope of the modulated signal, while the modulated signal has a frequency of a carrier. So basically, this is what is on amplitude modulation. Next, on frequency modulation, it's the same thing. This is the modulating signal. This is the signal that I actually want to send over to the recipient. This is the carrier, and again, you can see that the carrier also has a higher frequency as compared to the modulating signal. Now, let's take a look on the modulated signal. You can see that now the amplitude of the modulated signal is constant, which means that they have the amplitude of the carrier. But you realize over here, you can see that the frequency actually changed. So in short, the modulated signal, the frequency actually changed with the amplitude of the modulating signal. In short, the higher the amplitude, the higher the frequency. The lower the amplitude of the modulating signal, the lower the frequency of the modulated signal. So basically from here, you can see that the information actually appear on the frequency for the frequency modulation. As for the amplitude modulation, the information actually appeared at the amplitude, of the modulated signal. Let's take a close look on the effect of noise. So frequency modulation is often preferred over amplitude modulation because for several reasons, particularly in the context of radio broadcast and also communication system. Okay, so here are some key advantages of FM over AM. The first one, quite significant, is actually the better signal to noise ratio. Okay, FM is actually less sensitive to amplitude noise and also interference, okay, such as static from electrical device or atmosphere disturbance. Okay, since FM actually encode information in the frequency variation rather than the amplitude, hence the amplitude noise can be effectively filtered out at the receiver. Okay, so this is the key reason, okay, why FM actually dominate over AM. It's because of better signal to noise ratio, which means that, okay, basically this FM signal is actually less subjective to have interference. While AM, on the other hand, they are actually more prone to noise, okay, because it actually encode information in the amplitude of the signal, which can be easily affected by interference. Okay, let's take a close look on this. Okay, so you can see from here, okay, basically we have the AM demode, we also have the FM demode. Okay, so basically earlier on I mentioned about modulation. So basically this is what we call the demodulation. Okay, we actually want to recover back the original signal. Okay, so if you still remember, let's say this is the amplitude modulated signal. This is the frequency modulated signal. Okay, the noise can only add on to the amplitude. Remember this? The noise can only add on to the amplitude. Over here, you can see that the noise also add on to the amplitude of the signal. Okay, while we actually use AM, if you still remember for AM, we actually so-called recover the signal by following the envelope of the signal. So basically for amplitude modulation, the information is actually at the amplitude of the modulated signal. So therefore, when the noise actually exists, you can see that the noise will still present, okay, after you actually do a demo. Okay, so basically this is the quick so-called most issue about AM modulation. As for frequency modulation, again, okay, the noise will be added onto the amplitude. But because the information is actually at the frequency, and hence we can easily remove the noise by having a filter. So from here you can see that there is no more noise appeared at the outcome of the demodulated signal. So basically because of this, FM is basically much better as compared to AM in terms of the noise. So basically this is the key reason why FM is more utilized in the current world. Okay, so in AM, the information is carried in the change of carrier amplitude. Okay, which means that for amplitude modulation, the information is basically happen at the carrier amplitude. While in FM, the information is carried in the carrier frequency. Okay, which means that the frequency vary and the amplitude does not carry any information. At the receiving end of the FM system, only frequency component of the FM will be extracted out during demodulation. Okay, so any noise that will be imposed onto the FM signal, therefore will not have any effect on the recover modulating signal. Okay, because all the information only exists in the frequency. So basically, when the noise actually add on to the amplitude, it will not have any effect on the frequency. And hence, because of this, okay, basically any noise, okay, that is actually superimposed on the FM signal will not have any effect, okay, on the recovering modulating signal. Okay, so this is the key reason, okay, why frequency actually dominate over the amplitude modulation. Okay, next, okay, we also have a improved sound quality. Okay, FM actually provide a higher fidelity audio. Okay, because okay, it has a wider bandwidth. Okay, so this actually allowed for a greater range of frequency to be transmit. Okay, if your bandwidth is large, then you can use the whole frequency to transmit. And because of the greater range, okay, this normally will result in a better sound quality, okay, especially for music and high fidelity audio. AM, on the other extreme, has a very narrow bandwidth, okay, which limit the range of frequency that can be transmitted. Once we limit the frequency, okay, this actually led to a lower audio quality, okay, especially true for nowadays, the music is getting more sophisticated. Okay, so third point, okay, so less susceptible to signal strength variation, okay, which means that the signal strength change, okay, from top to the bottom, okay, they have lesser changes for FM. FM signal are actually less affected by variation in signal strength, okay, which means that the top and the bottom are much more so-called lesser variable as compared to the amplitude modulation, okay, which can occur due to change in distance from the transmitter or obstacle like building. Okay, so therefore, as long as the signal is strong enough to be received, the quality remain consistent. Okay, so basically, in short, if you are able to receive the signal, because there is less variation, okay, on the signal strength, so hence most of the time, okay, basically this will be so-called quite consistent and you will be able to receive the signal. For AM, okay, they can be quite significantly affected by the signal strength variation. Okay, they actually led to the fluctuation in volume and also the clarity. Okay, for AM, okay, you have a larger so-called mean, okay, between the maximum number and the minimum number. And therefore, because of this, okay, you actually led to a lot of so-called ups and downs in terms of volume and also in terms of clarity. Next, item number four, which is the efficient use of power. For FM transmitter, they can actually operate very efficient, okay, because they do not need to vary the amplitude of the signal. Okay, for amplitude, remember, okay, we need to vary the amplitude of the signal, and hence because of this, we actually use more power for AM. Okay, so because of FM, they actually allow for more efficient use of power as a transmitter can operate at a constant power level, okay, which is the carrier power. For FM, okay, the transmission power will be equals to the carrier power. While for AM, you actually vary. Okay, so based on the variation, okay, because of this, okay, we don't have a much efficient use of power for AM. Okay, for AM transmitter, they must vary the amplitude of the signal, okay, which can lead to less efficient power usage and also higher energy consumption. Okay, because you are going to vary the so-called the signal, okay, amplitude, let's say for this case here for AM. Okay, so therefore, okay, you actually very vulnerable, okay, to have this so-called higher power usage and also higher energy consumption for AM transmitter. Next will be on the reduced interference from other station. FM signal are actually less likely to interfere with each other, okay, because they are all separate by frequency. Okay, for FM, all the base stations are actually separate by frequency. All of them actually use different frequency to broadcast. Okay, so therefore, because of this, you are going to get lesser interference from neighboring station, for example. Okay, so this allowed for more station to operate in the same geographical area without causing interference. While AM, they are actually more prone to interference from another station, okay, especially at night when AM signal can travel further due to atmospheric reflection. Okay, so at night, the signal for AM can actually travel further, and this may come a issue. Okay, so this AM signal may come as an interference to other station. Six, stereo broadcasting. Okay, FM actually support this stereo broadcasting. Okay, so basically this allow for the transmission of two separate audio channel, the left and the right, to create a more immersive listening experience. So basically, in short, in order to have stereo effect, we need to have the left and right. And FM actually support this stereo broadcast. However, for AM, they typically does not support this stereo broadcast. Okay, although there are some AM stereo system, okay, but they are actually not widely adopted. Coming to the reason number seven, okay, so FM is actually less affected by multipath distortion. Okay, so I hope you know what is multipath. Okay, so FM is actually less affected by multipath distortion, okay, which occur when signal actually reflect off building, mountain, or other obstacles and arrive at the receiver at slightly different time. FM receiver can better handle this reflection without significantly degrade in terms of the quality. However, AM is actually more susceptible to multipath distortion, which means that they are actually very vulnerable to have multipath distortion. This can actually cause fading and also distortion in the receiver signal. Number eight, The last one will be the higher bandwidth. Okay, earlier on I did mention that FM signal actually has a wider bandwidth. Okay, so which allow for the transmission of more information and also the higher quality audio. While AM actually use a narrow bandwidth, okay, which limit the amount of information that can be transmitted, and therefore because of this, this actually result in a lower audio quality. Let's come to the summary. Okay, FM is generally preferred over AM because of the high fidelity audio broadcasting, okay, such as music and high quality voice transmission, okay, due to its superior noise resistance, better sound quality, and more efficient use of power. AM, while being simpler and also capable of longer range transmission, under certain conditions, they are actually very susceptible to noise and also interference. Therefore, this actually make them less suitable for high quality audio application. Okay, so with this, okay, I hope you have a better idea why frequency actually dominate over amplitude modulation. Let's quickly highlight the benefit and also the shortcoming, okay, for AM and also for FM. Okay, so this will be mainly for AM first. Many people believe that AM radio is actually updated and not longer relevant in today's world. However, AM radio still offer many benefits. Okay, for instance, AM radio actually can travel much further than FM signal. Okay, so this means that you can actually receive a better signal in a rural area or when tall buildings or other obstructions are actually between you and the broadcasting tower. Another advantages of AM radio is that its frequency are actually less susceptible to interference from electrical equipment or lightning. Okay, so this make the AM radio a reliable choice for emergency broadcast. Okay, so therefore in some country, okay, so basically police actually still use the AM radio broadcast. Okay, so as it explained, okay, AM is still a very reliable choice for emergency broadcasts. Coming to the shortcoming of AM wave, okay, so one of the main limitation of AM radio is actually it is very sensitive to atmosphere condition, okay, which can cause signal to fade in and also out. Additionally, AM wave actually carry the signal in the sideband. Okay, so the carrier don't have any signal. The signal actually appear on the sideband, either the lower sideband or the upper sideband. Okay, while the rest of the wave actually contain no information. Okay, for example, the carrier actually contain no information at all. As a result, AM broadcasts consume more power and they are actually less efficient in this regard. Finally, AM audio signal are not as clear or crispy as compared to FM signal. Next, let's come to the benefit of FM and also the shortcoming of FM. There are many advantages of FM over AM for broadcast. Okay, so in fact, this actually outweigh everything. So therefore, we don't have any more AM broadcasts in Singapore. Okay, so for one, FM signal are actually less susceptible to interference. Okay, so this means that FM station they can actually provide a higher quality listen experience, okay, with less static and also noise. Additionally, the FM radio wave actually carry more information as compared to amplitude modulation. Hence, because of this, this allowed for more immersive and better sound stereo broadcast. Imagine this, okay, if you want to carry a better sound stereo broadcast, which means that more data you need to send. And basically because of this, FM, they actually can send more data as compared to amplitude modulation. However, with so many rosy work on FM, there is also some shortcoming of FM. However, okay, so basically the benefit of FM actually outweigh the shortcoming. So therefore, FM radio is widely deployed in this current world. Okay, however, broadcast should also consider some potential shortcoming of FM radio. For starter, FM radio signal can be affected by interference from other electronics device, which may result in static or other sound quality issue. Moreover, FM signal can be obstructed by physical barrier such as building or mountain, can make them very difficult to receive in certain area. Finally, the FM frequency range is relative limit. Okay, means that station can only be heard within a certain distance from the transmitter. Okay, so basically this is the shortcoming of FM. Typically, okay, the range will be very, very short as compared to the amplitude modulation. Okay, so this will be my last slide. I want to do a quick comparison between AM and also FM radio. Okay, which is better? A few key difference between AM and FM radio significantly impact the listening experience. Okay, most of the time when we actually have this amplitude modulation or frequency modulation is simply for radio broadcasts. AM radio wave, they are actually longer. Okay, so they are actually making them, they are more susceptible to interference from electrical equipment and also the nature resource like the sun. Okay, so this often result in a cracking or static sound on AM radio. So basically you can hear a lot of hissing sound on the AM radio. Okay, while on the other hand, FM radio wave, they are actually shorter. Okay, so therefore because they are shorter, they are actually make them less prone to interference. As a result, FM radio actually typically deliver clearer sound quality as compared to amplitude modulation. Additionally, FM radio can broadcast in stereo, while AM radio is usually limited to mono. Okay, so this allows FM radio to provide a richer or more immersive listening experience. Okay, so if you prioritize the best possible sound quality, FM is the way to go. However, if you're aiming for a wider audience, okay, which means that you want to send a longer range and aren't any concern about the quality, okay, so therefore AM might be the better choice. Okay, so with this, okay, I'd like to end this discussion. This discussion, I have explained, okay, why frequency actually dominate as compared to the amplitude modulation. With this, that's all I have. Thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.